To everyone. Good morning, Juan. Well, my name is Guillermo Amaral, and I want to share with you some of the results I obtained from a very exciting and interesting project in which I've been. You're back. In which I've been spending some of my free time, and which is related to musical composition, using the computer, of course. But I think it's not because the result will sound naive from the point of view of musical composition, but because once again, in front of a domain from which I knew practically nothing, Smalltalk surprised me. On how good it is for exploring a new domain, first of all, dump all my previous knowledge about it and expand my knowledge and have fun at the same time. Well, the thing is that I started this project after seeing a work from this guy, Laurie Lynn. It's like an engine, his last name, which is called synesthesia, and in which he derived music from pictures using the metaphor of a sculpture. He started by removing pixels, information, in a similar way that a sculptor removed pieces of the stone in order to get the final art piece. So this is music from this picture, for instance. Then I was interested, so I searched for similar projects, in the line of deriving music from non-musical data, and I searched the web, and I found this. This is a great work from this girl, Hannah Davis, which is called Transprose, in which she derived music from literature. First she analyzed the emotions, chapter by chapter. Given a book, she analyzed the emotions, the prevailing emotions, and then, based on those emotions, she created a composition which was aimed at transmitting the same emotions. For instance, this is the music derived from Peter Pan. Yes. By a computer? No, automatically. Yes, both places. Emotion analysis and then creation of the music. Yes, as far as I know. Well, the thing is that I asked myself, what about generating music from the code? And what aspect would I like to reflect from my code in the musical composition? And of course, how to do that. And it turned out that, of course, the third part is the most difficult part, is the hardest part. But not only because of my ignorance about the musical world, but the thing is that when I went deeper into the musical world, I found that it's really difficult to decide what to do in terms of composition in order to reflect or, to transmit something. But, I had this naive idea. Nice code should sound nice. Not so nice code should sound not so nice. And a couple of weeks ago, I was telling this idea to some of my friends, and suddenly a scene from one of my favorite movies came to my mind, which I think well, of course, this is Back to the Future 1, and it's when Martin McFly is playing at the party where his parents are meant to kiss for the first time. And he's playing decently, but his father has some delays in kissing his mother, so the monkey starts to disappear, basically. And then he starts playing Little Bit Off. That's the basic idea I had in my mind. By the way, I love Martin. Well, just to give you a brief idea of what algorithm and composition deals with or is about, for those of you who don't know. Well, historically, if one thinks about an algorithm as a formal procedure, so in this case, it would be a formal procedure applied to the process of musical composition. Well, the thing is, it has been present almost throughout all our history. I mean, from ancient Greece until these days, the history is plentiful of examples of such things. I'm not going into detail of all the examples I found, interesting examples I found, just want to show you a couple. This is a game which is known as a dice game, and usually it is attributed to Mozart, in which he basically picked one measure out of, let's say, 300 measures, pre-composed measures, by rolling a dice. And then with those measures, he just put it together with other measures, just in the same way. So he introduced randomness into the process of musical composition. Several other composers use similar games or random processes. Going to the computer era, this guy in the middle of the 50s, Ledger and Hiller, who was a chemist and a composer, together with a guy, a mathematician named Isaacson, they wrote one of the first programs which produced an entire musical piece, which was later interpreted by real musicians. And this is really amazing. Well, so there are many techniques or ways to do this, and this is just my way of classifying them. There are tools or programs which are used for human aid, meaning that human composer takes the material produced by a computer to create or produce the actual composition, while others are just programs that create music. There are some of them which are deterministic, while others are stochastic, meaning that each time they are run, they produce a new composition. There are some of them that start from scratch, while others are trained, for instance, in a specific style. So they are aimed at producing a composition of the same style. And, well, this is simply as there are some techniques that take non-musical data, such as transprose, synesthesia, and what I did, while others just are within the musical world. So this is just a bunch of examples. They go from learning systems to AI. There are lots of things, knowledge-based systems, chaos, theory, and well, these are the ones I was interested, at least in this project. So now, going to this project, well, I've heard about MIDI, the standard MIDI, I never used it. So, well, I just wanted to use it, and since I didn't come with a layer support to MIDI, I decided to implement mine. So I started by just implementing the API, which is just a few of FFI calls. And then, as every small talker, I started to reify some MIDI concepts such as files, events, tracks, things like that, instruments, devices. And then I implemented also a petit parser to read files and my own MIDI player. Then I had a chance to get some sounds out of my computer, so I started on my basic knowledge about music. So I started by refining things such as notes, scales, major scales, minor scales, chromatic scale as well, chords, first triadic chords and then richer chords. And then I started to create the first composition elements, such as score, just a collection of measures, plus some other things, such as a time signature, which is a bad name for a class, and then the composition itself, and then a composer. So I have now the chance to put my hands and see what happens. So, as a way of exercising all these, I wrote tests of all these, but as a way of exercising, I implemented two composers, not based on code, but based on numbers and text. So I want to show them. So this is the composer hierarchy, and here are these two guys. One is based on text, so we just give it a text, in this case a fragment of one of my favorite writers, which is Cortázar. So if I execute this, I get this is just a modest GUI. And this is just the implementation of this composer is just a mapping. I mean, it maps letters into notes, and that's for the melody. As for the harmony, it uses a chord based on the notes on the melody. It's that as the root of the chord. So it puts just one chord in each measure, and that's it. And as you perhaps heard, there's a percussion there. I start to play with percussion to this day. So the number inspired composer. Well, here I can show you the mapping. The code of the mapping. This is just the code of the mapping, starting at some octave and some degree of some scale, I mean, the scale is chosen by the composer. Well, it just maps digits into notes, basically that. So I took the first 1,000 digits of a number pi, and then this is the composition. Well, the thing is that there's something I'm not telling you that it's regarding the rhythm, and I will say a few words in a few seconds. The rhythm is important, and it's.
If you change the map, that's the sound.
Yes, I mean yes. The shape of the melody doesn't alter too much the thing you call nice. But well, then I implemented these guys to help the composers to decide where the notes or the next note, the next chord. In fact, I implemented this for progression, which is just a list of chords or degrees. So, going to the code-based composer, these guys, well, suppose they are about to produce a composition, so they have this score or music sheet. So they decide several things based on the code in the first place, some metric, because at the beginning I thought that I wanted to have a configurable way of saying telling the composer, now look the complexity, now I want to hear another metric, and so it's configurable. And also they take a threshold for that metric. So based on that, for instance, they decide the scale. Well, the thing is that they calculate some statistics of this metric from the code, and then, for instance, if the average or mean value of a metric is below the threshold, they will use a major scale. Otherwise, they will use a minor scale. The idea behind that is minor scales are usually associated to sadder compositions, while major scales are usually associated to happier compositions. This is very controversial, I know, but in fact, we are assuming here that beauty should be reflected in a major scale, which is perhaps wrong. But the thing is that they decide that. Another thing, they decide the tempo. Again, based on the statistics, they decide the tempo in this way. Within a limited range, they say the higher the measure, the higher the metric, the lower the tempo, because lower tempos are usually associated to sadder things, sadder musical pieces, while higher tempos are used to happiness. Well, regarding the beats per measure and the beat unit, it is supported by the framework, but the composers just leave it without touching it. So, as for the melody, here I explore basically two alternatives, and then, well, Valeria suggested me a third one. So, the first of them is, suppose we have a method, then of course we have the source code. So we have the AST, so we can take some level of the AST nodes, for instance, the first level, which correspond to sentences of the method. And since I have a metric for them, I can use that metric. So I can just map that metric to some scale. And then, of course, if the metric surpasses my threshold, I can pick a node, an alter node, a node from outside of the scale, the chosen scale. This mapping is defined in terms of degrees, so changing the scale changes the actual nodes, right? And of course, it could span more than one tab. So the second alternative I explored was using the bytecodes. Again, having a compiled method, I have bytecodes, and then I have the type of the bytecodes or the family of the bytecodes. And I thought about this because I thought that bytecodes are likely to repeat along my code. For instance, every message sent, unary message sent, will surely produce the same family of bytecodes. So I was looking for listening patterns of bytecodes, if such thing is possible. But in this case, I mapped the type of the bytecodes to nodes. Again, with the same idea, nodes within a scale, and perhaps altering the mapping when the metric surpasses the predefined threshold. So finally, another alternative is using the method size. And here, put the literals, but there are blocks perhaps there. But the size of the method is a good metric. And this has to do with the granularity of the analysis, because if I use, for instance, bytecodes, and then I want to hear a project with several classes and thousands of methods, well, the composition will last all my life. Okay, so again here, just a mapping, the size of the method to some scale, right? So, as for the rhythm, this is very important thing. At the beginning, I didn't took it into account, but I decided to use something which is called a Markov chain. A Markov chain is just a state machine in which transitions have probabilities associated to them. So, and they allow a recurrency, meaning that the machine can stay in the same state. The rhythm is determined by, suppose we are in a state. Each state corresponds to 2-bit length composition, let's say. For instance, 2/4, 1/2 node. And of course, these states, some of them will be likely to be related to another, but the thing is that it works even setting the probability matrix with the same probability, that it still works. It's amazing. But this is a first order Markov chain. I mean, it takes only the last state when having to move from one state to the other. So the memory of this machine is just one step behind. So again, if the metric of the average, not the global, but local, because we are dealing with rhythm and rhythm for each note, I mean the value and the duration of each note. So if the local metric, I mean the metric corresponding to that note surpasses the threshold, well, the rhythm is altered, so they behave almost chaotically. I mean, there are several ideas to do that, but the thing is that rhythm is affected by the metric as well as notes and regarding the harmony as well. I wrote the harmony here using letters. So the harmony, I mean the chords, can be either determined by just the notes in the melody. I mean this G chord is determined by that note, or they can follow some chord progression. And in both cases, they, again, depending on the metric, will be altered so they sound strange. I don't know how to say that. Odd. So basically, this is the process of the code-based composers. So they first calculate statistics, then choose a scale, choose a chord progression, define a note pattern, define a rhythm pattern, then choose the tempo. Some of them can be rearranged. I mean, they are independent from another. Then finally they compose melody and harmony. So I can show you the three alternatives. First of all, I will show you the AST inspired composer on, for instance, a class. So saw that the facility class looks, it sounds well. But now see the Baiko inspired composer using the string class, and here I just define this threshold to 15 because I knew that in average it's a good complexity for bytecodes. So I think I added some annotations to the notes of this composition so you will see the value. So the last value is the complexity. So that's it. Finally, the method inspired composer, and now I tell him to use the project that contains the facility class, which contains several classes. So instrumentation. So the future work is huge because I found several things interesting. One of the things I told you is the order of the Markov chain. So higher order Markov chains tends to form longer phrases, and then the final composition is not just random wandering. So the scope changes. So this is one of the things I want to try, and then genre, and then instrumentation. I mean, MIDI provides that. So, but something related to genre is the use of percussion. That is something I'm trying during these days. So, well, the ultimate goal is to release this album for you. And I don't know if you notice the name of the song. So, for instance, The Strings of My Soul. And then, what is the point and the magnitude of love? Okay. So, that's it. If you have any question, only you, Francis. I'm open. Yes, and in fact, I did it. Yes. One of the things I tried was dissonance. Yes.
Do you know that there is music for some other rhythm like power sword and flute sword and those things?
No, I'm not aware.
Yeah, you do on YouTube.
Yeah.
I don't know how they use that music, but I will let you know that.
Yes, and in fact, one of the things I want to try is dynamic generation, meaning that music from the execution, from the runtime. Why not? Okay. So, thank you very much.